we want to look at inverse of n by n matrix, and we are going to consider a matrix A. If matrix A has an inverse B, then A times B will be the same as B times A, which is the same as equal to identity matrix written as In. So A is a matrix, B is the inverse of A. When you multiply, A times its inverse is the same as multiplying inverse of A times A, and the result proved. We are letting our matrix to be 2 by 2 matrix, 2 by 2 matrix, and the inverse of A, we are letting it to be B, which is also 2 by 2 matrix. Then, when you multiply matrix A, which is 2 by 2, with its inverse, which is 2 by 2, then the result will be an identity matrix, which is 2 by 2. So, alternatively, of course, you can start with the inverse of A, which is a matrix of 2 by 2, multiplied by the matrix A, which is 2 by 2, to give you an identity matrix, which is also 2 by 2. So, in this video tutorial, the focus will be to prove that. So, we can obtain inverse of A from A as follows. So, we can obtain A inverse from A as follows. So AB, C, D multiplied by X inverse, which is W, Y, X, Z. This, when you multiply this, it is going to give you, this is AW plus CX. The second element will be AY plus CZ. Then you go to the second row, you have BW plus DZ, then BY plus DZ. So when you multiply a matrix with its inverse, the result will be identity matrix 1, 0, 0, 1. That will be the result of that multiplication. A matrix multiplied by its inverse will give you identity matrix as shown there. So what we want to do now in the next stage, we are going to equate. We shall equate now. We are going to equate this element with their corresponding element. So the first one we will have AW plus ZX. This is equivalent to 1. The corresponding, the other one, BW plus DZ is equal to 0. You can call this one. This the other one here, we can call it 3, equation 3. Then the other one, you have AY, this one, plus CZ is equal to 0. Call this 2. The entry there is equal to 2. Then you have the final one, BY plus DZ is equal to 1. This element there, you call this equation 4. So from equation 2, we can make AY the subject of the formula. So AY, ay, this one, will be equal to negative of cz, as shown there. Here now we can make our objective is to obtain y. So y is equal to negative cz divided by a. You divide by a. Then from 4, this is from equation 2. Then from equation 4, this one, by will be equal to 1 minus dz. When you take dz on the other side. So then from here now you divide by b. You divide by b throughout to get your y. So y is equal to 1 minus dz divided by b. This equation here, you can call it 1, and this the other one. You can see the left hand side are equal, so we can equate. You can equate negative cz over a is equal to 1 minus dz divided by b. From here now, we can multiply both sides by b, so you will have negative c bz over a, which is equal to 1 minus dz. Then you can have negative c bz over a plus dz, which is equal to 1. The LCM here is a, so you have negative c bz plus a dz. This is equal to 1. That is equal to 1. Then we can factor z because it is common. So z factored will give us, you can start with this positive ad minus cb, everything over a. This is equal to 1. The objective is to get z. So z is equal to, you multiply with the reciprocal, so you will have a divided by ad minus cb. So we have obtained our z. Once you obtain our z now, we come here and substitute so that we get the value of y in terms of those other. So y, we had obtained up there that y is equal to minus cz over a. So here we can substitute to get y is equal to minus c over a multiplied by a divided by ad minus cb. You can see here the a will cancel. A and a, you'll be left with minus c over ad minus cb. So similarly, from this equation here, from aw plus cx is equal to 1, we can obtain the values of x at the W in terms of A at the A, B, C at the D as follows. So from here, we are going to, from 4, we can begin with the 4. BW is equal to minus dx, taking this the other side. Then, when we divide by B, so W is equal to negative dx over B. Over B that way. You can call this equation 1. Then from 4, AW plus CX is equal to 1. Is equal to 1. So instead of W, we can substitute these values of W. So A into bracket minus dx divided by B. This is give plus Cx. This is equal to 1. That will give you a 1. So this is minus A dx plus BCX over B. Over B. This is equal to 1. So minus A dx plus BCX. You multiply the denominator, both signs is equal to B. Here we can factor what is common here is x is common. So we can factor x. We will be left with BC minus AD, which is equal to B. That gives you B. So x is equal to B divided by BC minus AD. Minus AD. We can factor negative out. We can multiply the numerator and the denominator with the negative 1 so that the denominator become this way. So we multiplying numerator here. We can multiply here by negative 1 and the denominator by negative 1. When you do that, B will become negative, so negative B divided by this part here will become negative and this other one positive. So here you will have AD minus BC. So our x is equal to minus B divided by AD minus BC. So the next thing which we want to obtain is our W. So from 1, we found that our W is equal to minus dxB. So W is equal to this part here is equal to minus dx over B. W is equal to minus dx over B. W is equal to minus dx over B. So instead of x, we write minus d over B. Our x is minus B divided by AD minus BC, which is equal to. So this will result to B and B will cancel. We will have D into bracket AD minus BC. Minus BC. So our W is equal to D over AD minus BC. And you can see our x is minus B AD. Then now we can put all our values together, whereby our matrix, we let our inverse to be W, Y, X, Z. So we obtain the result which we have found our W, we have found it to be D divided by AD minus BC. Our Y, we found our Y to be minus C over AD minus CB minus CB. And we have found our X to be minus B divided by AD minus BC. Then we have found our Z to be A over AD minus BC. So this is the inverse of matrix A. So A inverse is equal to that. A inverse is equal to this value here. We can factor the denominator out because it is the same to have. So factoring the denominator, which is AD minus BC outside, we will be left with the D. We will be left with the D minus C minus BA. So that is how we obtain the inverse of a 2 by 2 matrix. Remember that our matrix A was having this element A, B, C, D. Those were the elements which our matrix A and A, B, C, D. And you can see here clearly what has happened is that A inverse, what we have done through all that long process, we have interchanged the element on the main diagonal or the element on the leading diagonal. Where you have A, we have interchanged it with the D. And where you have C, we have changed the sign. When it was positive, now it has become negative, minus C. Where you have B, we have also interchanged the sign, and now it has become negative B. And where you end D, it has become A. Then, when you look at this part here, AD is the product of the element on the leading diagonal. And BC, it is the product of the element on the other diagonal, meaning that the determinant of A is equal to product of element AD minus product of element on the other diagonal, which is BC. So, meaning that A inverse is given by, first of all, of 2 by 2 matrix, first of all, you shift the element, the position of the element on the leading diagonal. The first one, you shift with the other one. So you get D. Where you have D, it becomes A that way. Then you change the sign on the element, on the entries of the element on the other diagonal. And you divide everything by the determinant of your matrix. Determinant of A. So that was the procedure for deriving the formula for getting inverse of a 2 by 2 matrix. Thanks so much for taking time to study with me. For more video tutorials, tune on to my YouTube channel at Luke Aaron 1, so that you get other work concerning matrix. For the numerical example, we are going to consider it next time. If you have not subscribed, also remember to subscribe to this channel and also to click on the notification bell.